Okay, next few specials what on the TVET itself that we're going to put in, whether it's for the high anti-abrasion, or whether we're expecting some marking and then some what we have for after head and the pressure cleaners tops and because next. Okay, as for the main drive, we will use the ceiling pressure of this 10 bars, we want 14 bars, and then we have two dividend, and then we have our full excavation management system. Next. Okay, and then obviously it's also in a specification for the beam. Okay, like we're gonna put in, we're gonna throw in something for the backfill routing automatic system, and of course we'll fully monitor the wear on all the couplers. That's all then. Next. Okay, last one.
Quick question. Say, your conveyor belt system or your mud is very critical because the high lift that you have. So the conveyor belt system, if it fails, your whole tunneling process is going to grind to halt. Look into your conveyor belt selection or your mud. If not, you're using conveyor belt system, right?
No, no.
Then what are you using?
We're using skip.
You're going to use skip.
We're gonna use skip because we're gonna shift every time we pass through a shaft so that we can free up the last shaft, the last tunnel for the CPL pass through. So that's our plan. We're gonna have two sets of gantry crane and setup. We're gonna do so that we can free up. So this is how we want to finish up the movement.
So you're not using conveyor belt system.
No, it'll be too lengthy to dismantle and then we'll do that.
I want you all to look into the overall productivity that they are using. I'm just an opinion, or vision to have a look at. So, you guys need to look at their productivity. The risk that you have is movement of your segments, movement of people. Right now, you have to have a huge logistic of this because your mark is now coming out not through a conveyor belt system, it's going to come through the skips, right?
Yeah.
So overall, because this tunnel does not have a bypass opportunity, you do not have a bypass opportunity having bypassed in any segment. So you need to be able to look at the overall productivity based on the skip, the manpower going in, the TBM and everything else, all these things. Right? What's the longest drive for your tunnel that you're going to do?
It's about 4 kilometers. I think.
4 kilometers. It's the longest drive.
No, it means for one TBM, the longest drive is
Yeah, one TBM, what's the longest?
I think it's about 6 kilometers. Yeah. We make sure that we don't hit anything near 10 kilometers because the main drive design. So that is our plan. That's why we insert TBM. Yeah.
That will also mean that your shaft availability so that you can minimize your smart movement is also very urgent.
Yes. We plan that as well. Yeah.
Like, that's an opinion for Etihad to actually look into their schedule because these are all because now you have that conveyor belt is not there. I mean there is a parallel thing. So I'm not seeing your schedule, but I can't look into all that detail at this stage. But that is something become very critical. Right? Gantry crane. Using gantry crane, I can't tell me.
Yeah, we really gantry crane.
If the gantry crane fails, what's the alternative?
Okay, we have two, so that there is not on the same track that we can actually replace and pull it over.
Because the gantry crane fails, or if they lose, if you are hosting segments and the segments fall, right? Health and safety will shut down your crane. And then you either you continue, how do you continue to operate? There's a contingency risk. You need to be able to continue to operate without a gantry crane until you convince them that the gantry crane is functional. That's a health and safety requirement. So you need to have a contingency plan. If you stop your gantry crane because it's suspect that it is not safe to operate it. So you need to have a contingency plan to keep the continuity of tunneling. And now you have skip, you have manpower, all those things you need to look at logistics of moving. Parallel together with the train. So the train becomes a bottleneck if it fails. And it has failed. For me, both were stopped. In the stop tunnel, both were stopped. And they never recovered throughout the whole contract because they could not convince health and safety department it is safe anymore. Under those conditions, they had to bring in mobile cranes and operate. So those scenarios we need to play through to actually look at your logistics of what happens if your manufacturer of the gantry crane fails to actually give you a crane that is reliable. Right, so you need to look at that risk mitigate it with your manufacturer of your gantry kit. Make sure that you have a robust quality control plan on their gantry kit.
Yeah.
Okay. Inspection, visit, whatever, to make sure that they deliver. And you test it and make sure it's functional. You have a regime of maintaining it. Be serviceable in tandem with the manufacturer. I had an incident of segments falling. I have incident of the gantry kit failing because of power outages. In both situations, there was a big risk element of people working inside the car. Yeah, and then they both gantry kits I had to both were never recovered throughout the whole contract period after it happened. So, and based on the health and safety regulations, they were not given the permit to restart. So look into those risks of the gantry. All right, carry on. All right.
So, this on the testing commission side, so this one just quickly show the object of the plan. Basically, the dedicated and engineers for the beginning project. For each group, supported by all the commission specialists from our equipment system as well. This is just to show the sensitivity metrics for each role of each stakeholder. I think just keeping to highlight on the ONFD. So our intention here is to have the ONFD off from the beginning of the project now, so that bring the transition to hand over everything to them for the operation easier process. Next. This is just a high overview of process testing sequence. Right, so once the utilities are ready, we are testing for the process, process system. Then after that, only again testing the pumps, controls are ready, sewage comes in, do the steering, the biofilter to LCN, then we do the plastic initially for this level of next. So we choose a sample, testing sequence that we carry out. So some installation testing, commissioning is to work such water emission specifications. So for pump testing, for example, what we propose to do is try to think up the chamber and the valves. So we planning to choose one of the future lines for us to connect them very pipework. So they form a closed loop between the chamber and the valve. So by doing so, we will recycle the water. We do the pre-testing in pumps. Right. So easy. So that's the predictive testing. Then once the control systems are ready, then we do the all the switchovers, all the
That one picture is from where?
Yeah, the one on the right.
It's from I think from yeah, from our then also farm
Changi, like Changi, like. Director Fahad is the picture next to the pump. Exact cannot be exactly clean and all these things painting.
Yeah, that's from Changi. That's also
Okay.
yeah. So next. Another example from facilities, standard testing procedures. So I think the main thing I want to highlight is just from the system recognition test. So we divided that into two stages. So if you one stage, they do just ensure all the successful includes in the OCS functioning. And then the second stage of SVP is where we once the sewage are introduced to the HQS, we will have to sequence the seeding of the Indian vessels are hosted where the HQS are complete so the sewage starting. So during the time then do the seeding of the Indian, then you also have the license by so contribute to the so any excess HQS move consumer carbon. That's how we plan to for that. This is just a strategy.
Go back again. To achieve 99% shipping is either very low pH or you go very low to acidify, or you need to go high to alkaline level to bring it elemental sulfur.
Yes.
So either way, it's not in neutral area, because neutral area you'll never hit 99%. Right? You'll never hit 99% in that area. So if you tell me that your shipping and everything, the choice of the material that they use is in the neutral range, I don't know how you think that you need to revisit that.
Yeah,
What
we
is their choice? Because most of them choose acidification as a better option than alkaline level.
Yep.
The alkaline level is not good for bacterial growth, biological growth. It kills biological growth.
Yeah.
So balance that in the overall.
Yeah, I think in Singapore, those here, we try to really 1.8.
You have to tell them, you need to tell them.
Yeah,
You need to tell the designers. When they are convinced that they can operate between 6 and 8.
Yeah, so this is just a sequence of how we should get the down the one. Basically aligning with the change schedule that in our planning model. You have been planning, new case of the stuff. From that.
Yeah. This is okay.
Yeah, I think this isn't.
We haven't come to W yet.
Yeah, this is
These
okay.
suppliers, we have not actually shown what we want, this is basically following the recommended method. Okay, so this is the major construction equipment, permanent and the country, of course, in terms of TBM, we're still looking at various companies, including our in-house TBM suppliers, and Connect and CIG as well. Okay, this one. Yes.
Who's your in-house?
SUN, PET, and TRC, these are our own in-house TBM. Okay, so not gonna go through the factor management, I think the process is quite long, no?
Yeah.
Yeah. Okay, so again, it will be based on our baseline program. So we pick them up and then we have the lead time. So these are all listed here and then we will plan accordingly. So there will be a separate P6 program for the delivery schedule as well. Thanks.
Yeah, these are the some of the points we would like to highlight in terms of very important for the hydraulics point of view, the consideration and all. What are the some of the points we have seen based on the design we have received and all? Ravi is on the call.
Yeah.
Yeah, quickly go through this one and then we'll raise one by one. Yeah, please go ahead, Ravi.
Yeah, so this is the general RFP criteria and the DM guideline, which we already know that for the tunnel D by D is taken less than 60% and link saver is 70%. And as per DM guideline for the more 800 diameter pipe, it is 65%. And minimum velocity required for the self-cleansing velocity is 0.75 and maximum is 2.5. And one thing is here because 0.75 as per DM guideline should be achieved at a peak flow in a as per the hydrograph for a duration of 25 hours. And the manning component here has been taken as 0.013 irrespective of the material of the pipe, and same is also complying with the DM guideline. Yeah.
Next.
Yeah. So this is the D by D value in the D by D value in the tunnel system. So at the commercial operation, see that minimum and maximum value and the average value is coming around between 10% to up to 35%, 33, 34%, and average value is around 25%. And ultimate design year flow, it's going little bit more than 60% at some of the tunnel section, and the lower value is coming around 25% during the hydrograph flow of 24-hour duration. Yeah.
Next. Yeah.
Can you go next? Yeah.
Yeah.
So yeah, here, yeah, this is regarding no previous one. This one, thank you. So this is regarding the tunnel of the J2 part. We identified that 3 of the section of the pipe is not meeting this 0.75 meter per second velocity criteria for entire 24 hours. But some of the section are achieving, in the range of 6.5 hour in a day up to 2.5 hour in a day. This is more than 0.75 meter per second velocity. So if we need the velocity for the entire 24-hour section, even at the night duration when the flow is less in the tunnel section, then we have to adjust